Good day everyone, I'm Rana De La Cruz from BSc-3B major in Graphic Visuals, and today I'll be discussing the rules of communication using Cisco Packet Tracer. Let's begin with message encoding. When one device sends data to another, one device, example this one, device sent to another, this PC2, the message must be converted into binary signals, ones and zeros, that can travel through cables or wireless signals. So I demonstrate this by sending a ping from P0 to the route P0 to the route PC0 to the router 192.168.01. Watch as the packet travels through the switch toward the router 192.168.0.1. So each step shows how the encoded data moved across the network medium from PC0 through the switches and then the router, providing that message encoding allows information to be transmitted electronically. So next is message formatting encapsulation. So before a message leaves the device, it's wrapped with headers containing information such as source and destination IP addresses and MAC addresses. So let's examine the details of the packet in simulation mode. At the network layer, you can see the source IP 192.168.0.104 PC0 and the destination IP 192.168.0.1, the router, and the data link layer, the Ethernet frame, includes both source MAC and destination MAC addresses. This process ensures that the data is delivered correctly to the right device in the network. The third rule is message size. Every network limits the maximum amount of data that can be sent at once, called the maximum transmission unit, MTU. If the data is too large, it's divided into smaller packets before transmissions. So this rule prevents errors and ensures smooth data flow across the network, just like dividing a long message into multiple envelopes before sending. So now let's discuss message timing. Communication between devices must be properly timed to prevent collisions and ensures synchronizations. So for example, when I ping from PZ0 to PZ2, you notice that PZ0 waits for a reply before sending the next message. This shows proper timing and acknowledgement between sender and receiver. So each green packet represents a request and each purple one is a reply, demonstrating how timing ensures reliable communications. So each green packet represents a request and each purple one is a reply, demonstrating how timing ensures reliable communication. Finally, we have a message delivery options. So this define how data is sent across a network. Unicast is one-to-one communication, such as PZ0 to PZ2. While broadcast is one-to-all communication, where a device sends a message to every node in the same network. While multicast one-to-many communications, commonly used in the video streaming or conferencing. When PC5 sends a ping, it doesn't know PC6 MAC addresses. Next is my wireless communication. So my wireless laptop with IP 192.168.0.100 is also connected to the same network through the router wireless interface. So when I ping the router from the laptop, you see that even though it's wireless, the same communication rules apply: encoding, encapsulation, size, timing, and delivery options. The only difference is that the data travels through radio waves, instead of physical cables. So to summarize communication in a network, follow 5 important rules: message encoding, message formatting and encapsulation, message size, message timing, and message delivery options. These rules make sure that the data is delivered accurately, efficiently, and reliable between devices. Thank you for watching by Cisco Packet Tracers demonstration.